Hello everyone. Today we are going to discuss about very important conclusion of Bohr's atomic theory, which is calculation of radius of radius of orbit in which electron is revolving. That is calculation of radius of Bohr's orbit. Let's consider an atom with atomic number Z in which electron of mass m is revolving around the nucleus with some velocity v. The electron is revolving in a given orbit which is at a distance r from the nucleus, that is r will be radius of that orbit. What we have to calculate here, we have to find the expression for this radius. As we know that the charge on electron will be negative charge and its magnitude will be E. And the charge on nucleus of atom is positive charge, which is due to all the protons present in the nucleus. The magnitude of this total positive charge will be equal to charge on one proton into total number of protons present in an atom. As we know that electron and protons both have same magnitude of charge, that is 1.6 into 10 raised to power minus 19 coulomb, although the nature is different but their magnitude is same. So here in place of charge of one proton we can use charge of electron because the magnitude is same. Also, number of protons in an atom is always equal to atomic number, that is in place of number of protons we can use Z. So total positive charge in the nucleus will be equal to Z times E. Now in this charged system, that is charge of electron negative charge and charge of nucleus, that is positive charge, there will be some interaction. This interaction will be called as electrostatic interaction or electrostatic force. This electrostatic force is given by Coulomb's law. According to Coulomb's law, electrostatic force between two charges will be equal to K Q1 Q2 divided by R square, where K is called Coulomb's constant, Q1 is charge of one particle, Q2 is charge of other particle, and R is distance between these two charged particles. Here we can use Q1 for charge of nucleus and we can use Q2 for charge of electron. By using the value of Q1 and Q2 in this expression, we will get the expression of electrostatic force of between two charges as Kz E square divided by R square. Let me name this equation as equation 1. Here we know that the electrostatic interaction is between negative charge and positive charge. So this should be attractive in nature, and due to this attraction the electron should fall into the nucleus. But actually in reality this doesn't happen. The electron always revolves in a fixed orbit around the nucleus. So what happens here is all the electrostatic force is converted into another type of force which we call as centripetal force. Due to this centripetal force, the electron revolves around the nucleus in a circular orbit. Mathematically, this centripetal force will be equal to mv square divided by r, where m is mass of electron, v is velocity of electron, and r is the radius of orbit in which electron is revolving. Since we know that this electrostatic force is completely getting converted into centripetal force, so these two forces will be of equal magnitude. So we can equate these two forces. By equating these two forces, we will get expression for radius of Bohr's orbit. We can use this expression directly if velocity is given. This expression is Kz E square divided by mv square. K Coulomb's constant, Z atomic number, E is charge of proton or electron, m is mass of electron, and v is velocity. If velocity of electron is given in orbit, we can find radius of Bohr's orbit. If velocity is not given, we can compute this velocity from one of the important Bohr's postulate. The postulate says the angular momentum of an electron in any orbit will be always integral multiple of h by 2 pi. Mathematically, we can write this postulate as mvr is equal to n times h by 2 pi, where mvr represents angular momentum and here h represents Planck's constant. From this postulate, we can find the expression for velocity, that is v is equal to nh divided by 2 pi mr. By using this expression of velocity in second equation, we can name this equation as equation 2. By using this expression of velocity in this equation, we will get the final expression for radius of Bohr's orbit. The expression will be r is equal to n square h square divided by 4 pi square m k z e square. Here n represents principal quantum number, or we can say orbit number. H represents Planck's constant, which is known to us. Pi is constant, another constant. M is mass of electron. K is Coulomb's constant. Z is atomic number, and E is charge of electron or proton. By using the value of all constants, we can determine the final expression for R, that is 0.529 into n square divided by z. This is the simplest form of expression for R from which we can calculate radius of Bohr's orbit. But in this expression, we need to know only two parameters. First is n, that is orbit number, which will be given in question, and second is z, that is atomic number, which will be also given in question. After that, when you will find the radius of Bohr's orbit, this radius will be determined in terms of angstroms. Thank you so much.